when I was getting ready for this talk, I took a look at the various ways that AGCI has affected my career, and I was surprised at how often I've been here and what a big impact that this has made. And so thank you very much to AGCI. I was first here in 1990 when Steve Schneider gave the first Roberts lecture, and I don't really remember what Steve said, but I do remember at the end of it thinking, just as I remember thinking at the end of your talk, Bill, when does this man breathe? Because he was just talking. So he took a breath, and it's been wonderful. I've been here since 5 or 6 times ever since. I'm a political scientist by training. I'm going to talk today really heavily about how the political science might be involved in the global change debate. I feel like a lot of my career I've been a troublemaker, explaining why we don't get things done and so on. And I've always been amused that economists have somehow earned the moniker of the dismal science, because frankly, political scientists will tell you all the time why things can't get done. And all my colleagues at UCSD think that my main job is to help them get done what they know needs to be done. So our job as political scientists is somehow to engineer people out of the way and get the optimal thing done, when of course in reality political science studies political behavior in a scientific way. The theme of my talk is going to be, we're doing a horrible job getting most of the social sciences involved, and especially political science, and I'd like to explain a little bit why that is. I'd just like to say 20 minutes isn't long. It sounds like maybe 20 minutes isn't 20 minutes anymore. It's 15, but whatever it is, I will compress or expand. I'm an ideal gas. I'll compress or expand to fill whatever space is available. I'd like to make 3 points. The first is about the role of serendipity in careers, and then I'll talk a little bit about places where we could get the social sciences, especially political science, more heavily involved, and then what would happen if we were actually successful in doing that. We probably want to think a little bit about that question. My biography in a page. I fly planes in college, and so you have a Darwinian incentive to know a lot about the weather when you fly planes. And in college, I got a job with Steve Wofsy and Mike McElroy teaching as a teaching assistant in a class on the atmosphere. And I figured I know it all already, and please don't tell Steve and Mike that I knew nothing about the subject that they were teaching, which was atmospheric chemistry and physics. And so I learned over a couple of years very, very quickly a huge amount of atmospheric chemistry and physics. In college, the most interesting classes I took were about arms control and politics, and so I got a PhD in political science. I went to MIT and got a PhD in political science. I worked on arms control and the Soviet Union. Early on in my PhD career, the Soviet Union disappeared. When you're in the threat business, having your threat disappear is a very serious problem. Luckily, I was at MIT, and people at MIT just kind of wandered around different disciplines and so on, and so I wrote my first seminar papers thinking about what I was learning from Mike McElroy and Steve Wofsy and all the TAs in those labs about the problem of the day, which was the ozone layer and the politics of that, and kind of accidentally along the way did some of the early political science work about the international relations as they affect international environmental issues and so on. Because I ended up working on climate a lot, that meant I had to learn a lot about fossil fuels, as Marty would have told you about yesterday, and so I've spent the last decade or so deep in the major fossil fuel markets, oil, natural gas, and especially coal. I spent a lot of time visiting coal mines and looking at the globalization of coal and stuff like that. So, why am I telling you this history? Most of the key turns in my career have been kind of accidental. And I think that especially in the social sciences and the parts of social sciences that are not well organized around questions that are of importance to global change, the people who are heavily working in this area are kind of accidental misfits. And that's a problem, and it also tells us something that's important for, I think, AGCI, which is that if you're going to do programs in this area, this is a high variance activity. It's a very risky activity. A lot of what's really interesting is not lined up with the normal disciplinary incentives and so on, so we have to think carefully about that and strategically about that. So that's the first of the 3 points I want to make. Second, where are we doing well and where are we doing poorly in terms of engaging the social sciences? Here's one slide on where I think we're doing pretty well. I'm sure everybody has their own list and you're going to disagree with it, but please don't disagree until the Q&A period. I think we're doing well in areas where the social science questions are lined up with what the discipline is doing already. I think the integration of economics, macroeconomic impacts, costs and benefits, the damage functions, all those things we've done tremendously well. The whole field of natural resource economics is already well organized around this, and so bringing in global change questions has been, it's not straightforward, it's been challenging and so on, but it's aligned with the disciplinary incentives, and so you can imagine an assistant professor not being insane and doing a tenure track around this field. And Michael Hanneman, I'm sure we'll talk more about this tomorrow. We've done pretty well in terms of bringing in innovations and technologies, at least in some respects, and then we kind of go down the list. We've talked earlier today about some of the polling work that's been done. I think we're actually learning a lot more about people's attitudes and public attitudes and median voters and things like that and so on. Political philosophy, in my field, political science, the philosophers in some sense have done the most. There's now a pretty vibrant field of people thinking about intergenerational consequences, across the planet consequences, on non-market damages, stuff like that. Philosophers kind of have their head around this because, again, the incentives are lined up. Where are we doing poorly? I think we need to pay very close attention to where questions that really matter for global change don't line up with what the disciplines already are doing on their own or would reward on their own. I think that problem in the social sciences might be most severe in political science, but that might also be a lamppost phenomenon that I kind of understand the problems of political science better than other fields. We also have to remember that doing serious work in this area requires a tremendous amount of knowledge about what most of you in the room learned your first year in graduate school or already knew. And so when I look back on my own career, I've invested a lot of it in tents like this in Aspen, mainly under the guys, the tutelage of people in the Aspen Global Change Institute. I've invested a tremendous amount of time learning a lot of meteorology, oceanography, climate science, and I don't think you can do serious political science work on most of these questions without at least knowing enough of the fundamentals there. So we have to remember that the barriers to entry, if you like, or the activation energy, if you want to use that term, is huge, and you don't understand how huge it is until you talk to people who are living on, planet N, to use the earlier analogy. I think another difficulty in empirically oriented social sciences is that most of what's interesting in those sciences has to have an empirical signal. So we don't have the data sets, and the signal from climate so far, in terms of most human behavior, is very weak and confounded by lots of other things. So for example, there's an interesting line of work that's having a hard time getting published about the impact of climate change on civil war, on migration, now on voting behavior, a few papers on that and so on, where you're looking at climate as one of a dozen signals. And so it's very hard to figure out what's going on, and there isn't really a lot of empirical work. And so for fields that reward that kind of stuff, you're not going to see the incentive structure for people to do that. Okay, enough griping. Let me give you 3 illustrations of how much time do I have?
You've got another 7 minutes.
Okay, let me give you 3 brief illustrations of some kind of work that we could do. I'm going to focus on 3 ways that institutions affect political behavior and outcomes that we might care a lot about. There's other stuff that's really important. Bill mentioned earlier, interesting work on human behavior. There's a huge amount of work on how humans perceive risk, make complex decisions and so on. Diffusion of best practices, institutions. Most of what I'm going to talk about today is about mitigation, not about adaptation, but frankly I think mitigation is overplayed and adaptation is underplayed because of the underlying political incentives. So the first insight about institutions. We know a lot about international institutions and when they work and when they don't work. And I've always been mystified why everybody was excited about the Kyoto Protocol. It struck me as obvious from day one that it was going to fail, because the international system creates very strong incentives for countries to join agreements they know they can comply with and avoid agreements they can't comply with, which means that the content of the agreement is endogenous to the underlying political interests. You water down the agreement to the point where everybody will sign. If somebody signs an agreement that they can't actually comply with and they just don't ratify it, which is what the United States did, or they bail later, which is what Canada did. And so what you see in Kyoto is these kind of grand visions that the Kyoto is going to have this big impact on behavior. Here's the fraction of world emissions at the time that Kyoto was negotiated, the fraction of world emissions that were included in the targets and timetables that were listed in Kyoto, 60%. That sounds like you're making a difference. This is the fraction of emissions that were controlled around 2010 of the countries that actually ratified and stayed inside Kyoto. This is the fraction as of today with the extension of the Kyoto Treaty, after Japan bailed, after Canada bailed, and so on, and after other economies have grown, like China and India. And so you've got a few countries that are doing under Kyoto what they would have done anyway, and if you do the counterfactual analysis in a serious way, what you find is that the impact of Kyoto on actual emissions is tiny, very, very small. close to zero, maybe 200 million tons of CO2 equivalents per year, maybe zero, I'm not entirely sure, but basically nothing. And that's built into the structure of international institutions in this area. And so you need to be smarter about the kinds of institutions that actually change behavior, as opposed to just assuming that binding institutions that countries can choose willy-nilly which ones to join and they can control the content, that those institutions will have a big impact. We also know as political scientists a lot, in part from work that started in 1995 here at AGCI, that in complex areas where there's a lot of disagreement, international institutions are fragmented and diffuse as opposed to vertically oriented. So if you rewind the tape of history back to the early 1990s and you say, what do most people expect would happen on the climate issue? They expected the same thing to happen in climate as happened with the ozone layer, which is you have a single institutional framework, a single body of international law, and everybody's organized around that hierarchically. What we've actually seen in the real world, this comes from a paper that Bob Cohane and I published a couple of years ago, and a bunch of people are now doing work in this area to try and quantify this. What you see is actual institutions that have an impact on behavior are much more decentralized. So for example, the Montreal Protocol, which is on the ozone layer, not the climate problems, actually had a larger quantitative effect on the emissions that cause global warming than the global warming agreements. And other agreements in this area are having a bigger impact as well than the formal institutions charged with it. So you've got a decentralization of the system. And we could imagine doing some work where we brought together people who study this, most of whom know nothing or little about climate, and people who are modeling this with integrated assessment models and trying to build some of this into the integrated assessment model so we could start to understand this in a more serious way. Let me just say one more thing in passing about this and then I'll move on, which is the fact that the institutions, the content of the institutions is endogenous with underlying interests, and the fact that these institutions are decentralized is why so many political scientists are thrilled about the idea of working in small groups, clubs, what used to be called the coalitions of the willing, but then that got tarnished by other events, and so we don't call them that anymore, clubs. And what you see when you rank order countries, this is numbers of countries from the biggest emitter, China today, up down to the smallest, and then their total emissions, what you see is, this high concentration of emissions, and in fact, even higher concentration of the things that are going to have a big impact long term on our ability to mitigate emissions, R&D spending, patent activity, and energy, and things like that. And so it's not that political scientists are somehow opposed to the UN or we hate the UN or whatever it is, but the reason structurally so many of us are excited about working in smaller groups rather than big groups is because of this realization that the structure of the problem creates the illusion of action rather than actual action. I want to just talk very briefly about a second institutional question where we could actually make headway, and I think we know how to do this, and I could imagine AGCI having some sessions on this, which is about which technologies get adopted. So the standard integrated assessment model assumes that all technologies are available everywhere in the world, instantaneously more or less, and that all firms have the same cost of capital and the same risk appetite. Nobody actually believes that in the real world, but that's a convenient way to get started. But that's kind of a problem if you think that the technologies that are going to be adopted are generally long-lived, like power plants, and therefore the firms that invest real money in them, not kind of fake money, but real money in them, are going to be very attentive to risk. And so there are a variety of ways we can tweak these models to do this. Valentina Bossetti and I did this a couple years ago with one of the standard integrated assessment models, the WICH model. Jay Edmonds and his group and I are doing some similar work now with Jay's model, where if you tell the model, and the circles I'm going to show you are proportional to the total macroeconomic cost of stabilizing greenhouse gas emissions at a level that people kind of widely discuss. If you tell the model, you give the model perfect foresight, which is how most of these models run, pure optimization, full information, perfect foresight, neutral risk. The costs are kind of roughly equal, typically 1 or 2% of global GDP. Then what Valentina and I did is we put a dial in that approximates how risk alters the time horizon that firms see. So when firms invest in a very risky environment, they tend to invest in technologies that have a rapid payback, and they avoid very long-lived, highly regulated, capital-intensive structures. So we then started turning the dial. And what we found was that if you end up with dials that are consistent with the kinds of actual risk profiles that you see in the capital markets, that the costs multiply by a factor of 6 in the standard integrated assessment. This factor alone is bigger than all the other variables that most people in the integrated assessment community were looking at this time. I'm not saying this is right. I'm saying this is a kind of toy model where you can imagine creating other dials that are rooted in how we understand institutions. Why this matters, here's a slide from the latest IPCC Working Group 3 report. They've done some similar work where you do it in a much more crude way, where you tell the model that certain technologies are not available. like carbon capture and storage. And when you do that, the costs explode. And so the mitigation costs in the real world are probably going to be a lot higher than in these idealized worlds. I want to just close with this slide and talk about a third kind of institutional insight, or an area where if we got more serious about involving the social sciences, maybe especially political science in this debate, we could make some progress. When you think about an ideal policy to address a problem like climate change as an externality, is you have a carbon, I love the carbon tax. It's a just wonderful policy instrument. Or cap and trade, maybe people thrilled about cap and trade and so on. And we model it that way as a single instrument. So we've got a single externality, we apply a single instrument, we look at the optimal response in the system and so on. When you look at the real world, every single real society that has tried to regulate a complex externality with big political externalities as well uses multiple instruments. And in fact, you don't use market instruments for the most part, you use regulatory instruments because there are very strong political incentives to use regulation, even though it's more costly because you can hide the cost. And you can impose the cost on people who are not well organized politically. And politics is basically the art of stealing from the diffuse, disorganized interests and concentrating it on well organized interests. And so what we see in the real world is multiple instruments. Here in California, we've got a cap and trade program. 30 seconds and I'll be done. We've got a cap and trade program. Everyone's thrilled about our cap and trade program, how it's the world model and so on. When you look at the actual impact of the cap and trade program on California's emissions, and compared to the other policies, like direct regulation, it's tiny. This is the CARB. This is the people who are managing the cap and trade program. This is not some wacky lefty or righty group only watching Fox News or hugging each other all the time. This is the actual people who are implementing the program. This is what they expect are the numerical impacts of the different programs. Here's the cap and trade, 18 million metric tons, and then here's all this other stuff, all of which is direct regulation, the vast majority of which has a marginal cost on the economy much higher than the $10 or $12 a ton that the cap and trade program is running at right now. Why do we care about this? We care about this because we now know politically which kinds of policy instruments people will implement, and we know that there is one of the biggest methodological and kind of empirical challenges now is to look at the interaction between different policy instruments. That's a big deal. And if we could develop some methods, toy methods initially, to try and do this, bringing together economists, political economists, modelers, who study economic impacts and so on, that would be a huge deal, and maybe also an area where AGCI could have an impact. Thank you very much.
I think we have time for a couple of questions. Yeah.
I love this last slide, but I want to go back to one of your serendipity slides. I'll say thank you for that point about getting to a career by accident. And I was actually telling this story to just earlier. I too, as a social scientist, got to this point serendipitously. So I will not bore everybody with my version of that story tomorrow or Thursday when I get my 2 cents. I have a question for you about this forecasting, or at least thinking. If you had to do your best guess on regulation, which I think is a great, I haven't heard much about regulation so far in this meeting, and I think it's something we need to talk a lot about because it's very viable. But regulation in a place like China or India.
Yeah, so first of all, I think that when we look back on this experience, we mitigate, that 80 or 90% of the real effort in mitigation will be done with direct regulation, not with markets. As somebody who loves markets, that horrifies me, but I think that to be true for the underlying political reasons. When you look at countries whose administrative structures are not as strong, what you see is regulation that, first of all, is generally more expensive than optimal, and you see regulation that gets oriented around the areas of strength, which will be different in China and India. So in the Indian case, some of this is going to relate to direct Indian control on the parts of the economy where the state-owned enterprises are very strong. In the Chinese case, I think what we're going to see is the most important impacts are going to be the regulations that line up with the party, the structure of incentives inside the party system. And our lab I run a lab that does studies highly regulated industries, and we do comparative work around the world. And it's really interesting to see how in the real world leverage comes from areas where the administrative structures line up with what countries are also always able to do. Let me just say one last word on this before we go on, which is both those countries and essentially all of the emerging economies, of course, are thinking about climate in a very different way, which is they're mostly thinking about other problems, and then they're linking that to climate or pretending to link that to climate. And that's one of the reasons why I've been spending a lot of my time working on soot. Because when I think about areas where you can really demonstrate political capital and so on, and then build on that, soot, because it lines up with local, tangible harm, is as a political scientist, more beautiful as an entry point than CO2. The CO2 problem is impossible to solve without a big change in technology because it requires high upfront costs for distant, uncertain future benefits and long-term cooperation between countries with different interests. It's not surprising that we're doing like nothing on mitigation and we're going to have to do a lot more on adaptation than would be optimal.
One more question, Marty, and then we're going to move on.
Yeah, maybe I don't know how this is grouped in California, but where do things come in like feed-in tariffs or direct subsidies for installing solar panels? I don't know which of those programs. Is that under the renewables portfolio or?
Yes, yes. So
Okay.
California,
And that's a very small piece, actually.
yeah, so I would say this is one of these areas where people, so let me say something politically, I guess almost all my career has been politically incorrect, so I won't stop now, but I think most of this stuff about renewables is just complete vaporware. When you look at the numbers on the ground, except in places where the incumbent electricity is incredibly expensive, like Hawaii, where they're burning oil as the rival, so almost anything is cheaper. Except in those places, the renewable energy business is very, very subsidy dependent. And in the places that have a lot of those subsidies, there are all these other programs that's going on as well. And so the actual leverage that comes from that is very small compared to the leverage that comes from big nuclear plants. Well, California's got a lot of problems in there. And the switch from coal to gas, of course, has been huge.
Thanks.